close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Finding life along the way, melodies we haven't played. No, I don't want no rest. Echoing around these walls, fighting to create a song. I don't wanna miss a beat.
All right, hey everyone. Hopefully everyone had a great Tuesday. This is getting down to the Christmas holiday, so it's coming around to the end of the year as well. So hopefully everyone's kind of getting ready for that. I definitely am. Have some personal things coming up in the next couple weeks. So it's I put out on Twitter actually right before the stream that this will be the last stream of the year. So I won't be seeing you guys till 2022 after this stream, but obviously I'll be available. I'll be on Twitter and other ways to connect with me. So I'm trying to think what else. Oh, I wanted to apologize for the late start. It was only a couple minutes, but I updated OBS and there are some issues streaming or connecting with YouTube, and they had some new integration that I was trying and it did not work. So I'm actually going to, before I start, go ahead and hey Ganesh, wow, that was quick. How are you doing? I am glad you're here. I'm gonna go ahead real quick and throw up the YouTube chat on stream so that way you guys can see. Hopefully you can start seeing this. Cool. Okay. I have that up. Not too worried about that. Let's see. Hold on real quick. Man, I wish I was better at some of this stuff. File, docs, here we go. YouTube, apply, close. All right, so Ganesh, you're doing great. Looking forward to learn more. Good. I got a the last stream of the year, I figured I'd end with something good, something new, So we will, I guess, before I jump in, I at least want to provide a little more detail around kind of next year, my thoughts with that, with streaming and everything. So the streaming definitely won't stop. I'll continue to dive into the DevNet Expert a little more. I know over the past couple weeks we've kind of veered off that path and started looking at CML, and tonight we'll be diving into another tool as well, another platform. So we'll get back on track in the new year. It's just I have to kind of recalibrate. I gotta definitely have these next 2 weeks or so. I'll be recalibrating and figuring out kind of what's next and what's the best way to move forward with some of these topics. Because recently I reviewed the exam topics again, And I'm realizing, what we go over on streams is great. I think everyone seems to be learning a lot of good questions coming in through chat. It's just that now I think what we need to start doing in the after the new year is kind of diving a little deeper. So a little more into, okay, this exam topic says this, we're going to accomplish this during this stream or these two streams. So obviously the streams being, roughly an hour and a half, 2 hours long, you won't be able to get everything in. So, it might take a couple streams to go over it. So I will definitely aim to get at least one topic completed within a stream, or at least have a focus on it. And then obviously, like I've been saying, I am working in the background as well. Obviously, if I only studied twice a week for an hour and a half to 2 hours on stream, it'd be a pretty rough test attempt, to say the least. So, yeah, I'll definitely recalibrate a little bit and, hopefully provide some sort of outlook for 2022, when we're back. But tonight, what I thought would be neat is to take a look at this new, I guess you could call it a platform, really. It's called ContainerLab. And if you follow me on Twitter, this probably isn't news, and I probably was blowing up your feed on Sunday. Yeah, Sunday. This past Sunday, I was heavy into ContainerLab. I've read about it in the past, and honestly, the one reason I kind of shied away from it was, as you can tell with my, DevNet Dan, I kind of started with Cisco, right? And so, most of these tools I look at, one of the default things I go to is Cisco, right? That's mostly what I know anyways. And at first, ContainerLab was mostly focused around Nokia. I believe that's where the maintainers actually work, if I'm not mistaken. I could be mistaken with that. So Nokia, Arista, Junos, I believe, is also in here. And we'll take a look at the different device types tonight as well. But yeah, I was like, man, like different device types, which is fine. Like nothing was wrong with it. But then I also thought about it a little more. I was like, man, we're, containers? Like we're at that point? But I was wrong. I spent this past Sunday labbing this up and getting just a basic topology down. And let me tell you, this is a sleek tool. This is something I personally see as potentially being the future. There's definitely a lot of cards that need to fall in place before we kind of deem it as the future. But I will say, with what's out there now, and then kind of where this tool is, it definitely it's lightweight. It's very easy to put most of its configuration within version control, and then honestly, I think the biggest reason is its simplicity and its dependency really on Docker and containers. As most of you all probably know, a lot of CI/CD pipeline work is done using containers. Spinning up containers, performing testing or the deployment with containers. Microservices obviously is just one big mesh of containers. So like we've known for a while, containers are the future because of its portability, being very lightweight. The list goes on. So the fact that we can virtualize and more or less containerize these network operating systems and be able to create a topology, wow, you know what I mean? It's pretty impressive, to say the least. So I won't fanboy anymore, but I will say I was very impressed with what I found, and also just going through the process of getting it up and running. So I figure what we'll do is just quickly, try to go over high level, like what we're even doing here. And then I'll show everyone and kind of go through the process of deploying a lab. So yeah, that's kind of what we'll be doing tonight. obviously, if you guys have questions, please put it in the chat. I personally prefer a much more collaborative effort and chat during these streams because I've looked at this before. I've deployed the lab, but more or less it's to show you all kind of what's possible, and also hopefully inspire you to want to try this yourself. And I'm obviously here to answer any questions, be the punching bag for your frustrations, whatever I can help you with. So, all right, with that, like I said, I'll take a look at chat as we kind of move along. But we'll just go ahead and get started. So, containerlab, I kind of already highlighted over. It's the idea of building a network topology using containers, right? And it's a little different than, say, GNS3 or CML or what's the last? EvenG. Those are kind of the three platforms I'm familiar with, CML being the most recent. And you can see that, there really isn't like a GUI interface to it, right? It's more or less, just like a container, you would define, like in Docker, you would define, Docker compose file, right? Or a Docker file. So, if we jump over to Quick Start, right? So we have a topology definition file, right? And this is what a topology would look like, right? It's a YAML file, essentially. So I'm not going to go through each individual instruction. We'll definitely take a look at that as we go into kind of the practical side of things. But you'll kind of see that, installation's pretty straightforward. There's actually a separate installation page. And I personally use the install script here. And you can see it, detects your operating system, installs the relevant packages. I use the script that uses curl to download and install the release. But you can use package managers, apt-yum, APK. You can actually deploy it as a container, so you can pull. It's actually a container itself. I'd be interested on seeing how that runs. And then you'll see like WSL, Mac OS, and so on. So pretty much it's across the board. You can install it on a Unix-based system. So pretty neat stuff. All right. So you're probably wondering, how's this even work, right? So, Docker, when you deploy Docker containers, Docker has its own kind of bridge, I guess you could say, and I should call it just a network, right? It's a layer 2 network that you can manipulate, you can re-IP and whatnot. And basically what Container Labs does is it deploys your devices, right, as containers, and then it connects into your containers on a given port. And that given port can be different depending on the type of device. So for example, with a Cisco CSR, what I've deployed and I'm using, it goes into ETH1 or Ethernet 1. So ETH1 is not usable because that's the management port per se. So you have to your first available port is really ETH2 or Ethernet 2. So, that's kind of interesting, but it's also very practical. I mean, at least in my head, right? I mean, some people might be like, well, you can make a virtual console port, or there's a management port on these devices. And in the case of some of these devices, there might be a management port, like a dedicated, management 0 or whatever. But I found it pretty practical. It's pretty easy to understand. So, let's go over a simple topology file. So they have phenomenal documentation on all of this. So I won't go through each little section and each bullet point. And I'll actually, what I'll do real quickly, so that way I'm not kind of reading off, or if I'm scrolling too fast for someone, Let me go ahead and pop this in the chat. So I'm actually I put this quick start guide in the chat, so that way you can kind of review it yourself, or jump around if it's boring to you, or or hopefully I explain it well enough. But so I actually find that this topology file is very relative to like PyATS testbed file. So for those that aren't familiar with PyATS, it builds out. It's not just like an inventory, right? Like Ansible inventory, you can describe the devices and whatnot, but PyATS testbed, you could describe the device, you could describe the interfaces on the device, you could describe the links that connect the devices. So it's a lot, right? It's a lot that you could describe, and you could create relations, because at the kind of the underpinnings of PyATS is everything's a Python object. So you have your inheritance, your encapsulation, your modularity that object-oriented programming kind of brings to the forefront. And so at least, obviously this is very basic topology, but you kind of can see it here. You describe the nodes, you describe the kind, and we'll kind of get into that, the Docker image that's used, and then down here you'll see links. And basically this is where you describe what port connects to, what port from each device connects to each other. I probably explained that very wrong. But just picture a link, right? And you router 1, router 2, and then let's say port 1 on each of them. So port 1, router 1 connects to port 1 on router 2. I think that's a better example. So yeah, it basically you just pair them together in a list, and yeah, that's pretty much it. So here, we have a name of the topology. We put the topology as like kind of the top level key, and then within that we have nodes and links, right? And then under nodes we have a device called SRL and CEOS. The kind, so to touch on this, and I'll actually just move up to the user manual, I believe. Yeah, so kind actually refers to, this is a really good example. ContainerLab launches ContainerLab launches, wires up, and manages container-based labs. The steps required to launch a vanilla Debian or CentOS container image aren't at all different. On the other hand, Nokia Linux and Arista may be very different, right? So that's kind of what the kind does. Kind, you have to be very specific. And you can see down here the different kinds that are supported. And so let's say, going back to our example, we'll be using a CSR. I might be missing it. Actually, it's not here. Interesting. So it's not in this list, but it is over here under kinds. It's right here. So you'll see that. Where's it at? Okay, yeah. Cisco is identified with VR-CSR kind in a topology file. So along with that list, you basically can use this, like the first part before the dash of these page names, to identify the kind. And like it says, it does all kind of the bootstrap and the kind of that setup and configuration. I think a very basic example would be the naming of the interfaces. So where, here you can see SR Linux has the interface name is E1-1. Whereas CEOS for the Arista device is just ETH1. And the same goes with a Cisco CSR. It's just ETH1 as well. So, but let's say, maybe there's one that's just G1 for Gigabit Ethernet 1. So that's kind of what the kind helps you with. The image, that one's pretty straightforward. That's the Docker image, right? And here's a good example of, the Docker image name, and then anything after the colon is a tag. So that's going to be super important with the CSR, because the CSR isn't a native Docker container, or isn't a native container, right? So instead of just saying, by default, if you did like a Docker pull, you would be pulled without a tag. If I just said Docker pull CEOS, it would just pull the latest, the image with the latest tag, right? But the CSR, because there's really no latest tag, you have to put, it requires a tag, and it generates that tag, and we'll take a look at that. I don't want to confuse you now. Julio in the chat. Hey, Julio, you are the man. You got me on this. So, Julio PDX in the chat. He's the one that kind of got me started with diving into it. He put out a really good blog article. I won't say too much more, but just keep an eye out on Twitter. Probably tomorrow. Might have something myself coming. Might a little surprise on. So just take a look at my Twitter tomorrow. But he did a really, really awesome blog post on all of this. He actually went above and beyond, I would say, because he integrated, I believe, Nornir and some other kind of a CI/CD pipeline flow into using containerlab as well. So pretty good. He has some good stuff. Yeah, definitely Ganesh. Yeah, he's the guy. He's the man. So glad you're here, Julio. And his comment, I didn't even read your comment. His comment was that he's really blown away by the docs and everything explained really well with great examples. I totally agree. I think the docs are very well organized, and they don't run on. So Julio says stay tuned on the next episode. I can't wait for a possible blog. I can't ruin the surprise, but let's just say you might be getting a shout out. So anyways, so that's the topology. We already kind of talked about the links down here, but before we go into that, let's just open up nodes, kinds, network wiring concepts. Yeah, so if you want to learn more about kind of the networking piece, because this is what was kind of, this is kind of what was not confusing, but this is one that I was like, if I'm going to get stumped on this, it's going to be the networking piece. Because I'm familiar with how Docker deploys a Docker network's deployed and the different parameters and controls you have. But all of this happening behind the scenes, and on top of it, a Cisco CSR that's VM based, that's not a native container. I was like, yikes, But I think they do a very well. They have a very good explanation of kind of how the management network setup that we talked about. The Docker network setup, and then there's basically a virtual wire that gets connected into all your devices, so that way you can easily access them. So this is actually using that test topology. Actually, it's slightly different. So so this is another way. Like, this is what I'm saying. Like, you kind of need to dive in yourself to the documentation, because you'll see here they defined a kind for SRL. Obviously is its own. Like, if you look at the list of kinds, SRL's in there. But you'll see that they put a type and an image, and basically when they create nodes, they just use the SRL kind as kind of think of it as like a template, right? So let's say I was to deploy 20 of these, it would probably be best to define under kinds, define a template per se, and then use that 20 times. So that way you're not doing image under defining an image and defining whatever underneath of each node. So, but you'll see here, like, here's the Docker network called CLab, the IPv4 pool that they use. It's just a /24 network. The bridge with the gateway IP here, and kind of how everything's connected. So you see what I mean, though? Like, that is like a awesome diagram. Like, from this, without even really spelling it out, I could tell you the pool of IPs they use. Since it has a subnet mask, I can tell you, all the available IPs, the gateway IP, the IPv4 and IPv6 gateway, and then kind of how it's set up, right? You have your Docker bridge, the virtual Ethernet connections. So super simple. Yeah, so like I said, I'm not going to read through all of it, but you can see, you can kind of go through this and understand, okay, you can actually set your own management network. So if, let's say, you wanted to use a different IP range, then I think the default was 172.20.20. If you wanted to use different IPs, you can do that. It kind of goes through that in this as well. Tells you, even goes down to kind of what the MTU value is for the default Docker network, and then how to change that, how to get the lists, the network details. Dude, this is awesome. This actually, I think, is one of the best diagrams here. Oh, wow. Okay. I didn't realize you can click on them. This is great. So you'll see, like, this explains that how each individual link. So, right, you kind of have the links, the top level key, and then a list of the endpoints. So you'll have a list item for each link. So here we have SRL node with the interface E1-1 connected to the Arista EOS device on Ethernet 1. So Ganesh says, one, as I have, is how to bridge your PC LAN with containerlab management network. Did you guys figure it out? So I haven't got that far as like exposing the. I'm assuming that's what you mean, like exposing kind of the network, the Docker network. The thing is, though, like your local PC, which I'll kind of get to it. You can, on your local PC, connect into the Docker network, because obviously it's the Docker host. They're on your PC. But as far as exposing it to, let's say, like another PC on my network, I haven't got that far yet, so I can't really answer it for you. But I'm sure it's in here. I'm sure, like I said, I just haven't had time to kind of review all of it and then lab it up. So, but I can tell you, I can get from my PC into the management Docker network. So, yeah. In addition, these are talking about, I think these are two different Docker networks. Yeah, so. Oh, and this is a really neat feature, and it shouldn't be undermined. I think this just shows you kind of the level of detail that the developers and the maintainers of this project, are looking at. Is, by default, you create the host names, and you obviously can't use the host name unless there's an A record or record in your local host file or on your DNS server. But part of the deployment process, once you define your topology and deploy the lab, is it will create static DNS entries inside your etc host file. I think that's awesome. That is like we love our users, so we're going to make it easy on you. Because what happens is you can create the DNS entry. It creates the DNS entries for you, and then whenever you destroy the lab, or what they call destroy the lab, it removes those static entries. So like you don't have to go through and manipulate DNS, whether it's on your home DNS server, corporate DNS server, or even your local host file. So I think that's such like a little nice to have. So, and it's obviously it's at the bottom of this link or this page, but hopefully people don't miss that. Okay, so we kind of got through that. Configuration artifacts. So this kind of goes through persistence, storage persistence. How do you keep your configuration files? When you save your files, or I'm sorry, you save your config, how does it get stored? Where does it get stored? All of that's in this configuration artifacts. We already went through kinds, network wiring concepts we just did. The nodes we just skipped over. But there's a lot of different things you can, a lot of parameters you can put into your, you can define in your topology file. So you can see the different ports to connect. So if you're out, you want to bind some different, so this actually could be maybe, I just don't know if you can access it. I would assume you can access it on your local LAN. But Ganesh, this might lead you somewhere. This is kind of binding your host port to your container port. So if you wanted to bind a particular device to your host port, you could go to, localhost port 8080 or whatever, right? And in this case, it would map. Well, in this case, it maps port 80 of the host is mapped to port 8080 on the container. So I'd be interested on how that worked. The only thing is, I don't know if it will work outside of the local host. Because, for example, like in Flask, right, if you wanted to boot up a dev web server, right, your development server, then you could boot it up and just say, in the configuration, you could say 127.0.0.1, and so you could go to localhost port 5000, 8000, whatever it is, and go to it. But someone on your network couldn't access it using your IP address. The only way that happens is if you expose it on, your actual. I don't even want to say the public IP, but like you actually expose it on your NIC and you expose it to the IP address. If that makes sense, right? So there is a difference between, mapping it to your local host and then allowing others to connect to it from your network. But that might be a good place to start. Adding environmental variables. And you can see, like, I'm not going through like how to do these, but you can see how easy it is. You just have to kind of know the order. So you can either put it under a defaults list. If you have multiple environmental variables, you can put it under the node itself. If it's just an environmental variable that's specific to the node. Set up a user to run a containerized process. Entry points. So you kind of have to think of this too. Angel says, hi, Dan. Hey, Angel. Hey, I don't know if I saw you in the last stream, or at least I don't know if I saw you in the chat. But thank you for stopping by. This is my last stream of this year. This year of 2 weeks left before the holidays. So, yeah, Ganesh, if you figure that out, feel free to message me on, put it in chat if you figure it out before the end of the stream, or message me on Twitter or however, because I'd be interested as well. But what I was going to say was you kind of have to start looking at some of these commands as, if you were to set up like a Docker file, right? So some of the keywords like entry point, CMD for the command prompt. There was another one too. I think I might have passed it. Oh, environmental variables. At the end of the day, these are containers, Docker containers, right? So you kind of have to treat it as such. So some of these will translate just as you would write in a Docker file. So Angel says is recorded. I checked the video after you went live. Oh, okay, got you. Yeah, it is recorded. If that's what you're asking. Yeah, the last one is recorded, and this one obviously will be as well. Okay, so you can see like I said, I don't want to go through all the different, but you can see there's a lot of options. The two that are interesting to me, and I'm just mentioning them because I'm kind of going over them, is that you can put hard limits on your memory and CPU utilization. So this is something like if you plan to, like tonight we'll be looking at the Cisco CSRs. If you plan to run like 10 of them, I mean realistically, that if a minimum is 4 gigabytes of memory and 1 CPU, I mean you're looking at 10 CPUs and 40 gigs of RAM. So, and it could scale above that. According to this, that container runtimes do not impose any sort of constraints. So a container can use as much as the scheduler allows. I mean, that kind of is like, okay, well, it can blow the top off. So, yeah, so that I don't have them set in my demo environment. Like I said, I just got a very basic topology. So, yeah, this is a cool page and a good one to take a look at as well. We're not gonna read through this one, or like go into detail, but you can do packet captures on your devices or on each of the lab, just like you would GNS3, even G. It's a little different on how to do it through containerlab. The VM-based router integration, not gonna touch on yet. That's the key, not yet. Published ports, we're gonna come back to this. Actually, I'll just quickly highlight it. So published ports, and Ganesh, this actually could, I don't want to say it would solve your problem, because this is kind of like, I think goes a little beyond, but this published ports page is really interesting. I spent a good amount of time actually like reviewing this. So it uses this site called mysocket.io. Let me open it up real quick. And think of it as like ngrok, if you're familiar with that, NGROK, where basically you can connect to a device. Kind of gives it a public IP address, right? That you can access the device. So what publishing a port does, or publishing a container, as they would say, is you could, using this mysocket.io, you could publish a container. I mean, really think about this. A container you could publish for anyone over the internet to access and use. So what this allows in the use case, and besides it being really awesome, what this allows you to do is, create a lab in your environment and then share it with people to collaborate. So something that would be neat in this case, like they say, an interactive demo, training, sharing with an audience for hands-on experience. So what would be neat, like in this case, is like if I published my topology, right, the 2 nodes of my topology, and provided the right parameters, the URL, whatever, however, you could go through mysocket.io to figure out, accessing it, and gave you guys permission. People watching this, in stream, you guys could actually access this lab right here on my computer. This felt a lot like what we did with John, the live share with VS Code, where it's like, oh hey, join our coding session, right? I thought that was mind blowing. I was really hyped. That was really cool. And that authentication is kind of through Microsoft itself, or GitHub. You could use a GitHub account or a Microsoft account, whereas this is through a mysockets.io account, where you register, you get a token, you specify what you want to share, and then you have to add a mysocket.io node. So that's kind of like the key formula to this. Is it's not just like you're saying, oh, I want this one container, right? You're saying, okay, if you add this node and you register it, then that's how they get access to your lab, right? Or they as in external users. And you can see here that you can see what ports are published, how to access them, what's the name of the actual lab, but then what's the name that mysocket.io gave it, and then the ports that you can access them on. So and then it kind of goes through like the security aspects and then troubleshooting. So I have not tested this. This would be very cool. This would be very cool to figure out, though. I would obviously need, some people's help, but it would be very cool to like lab this up and be like, oh, okay, hey, can you access my lab, right? Kind of pretend you're like a coworker, right? That's like, hey, check out this lab. Do you think it's configured correct? Or I configured this lab. Instead of me making a video about it, how about you just access the lab and kind of try it out yourself? So, very, very cool stuff. Multinode Labs. I believe this is just for across multiple VMs. So if you have to install containerlab in multiple areas, that's how this would work. Yeah. So like you have a management network that reaches across. I honestly didn't really look too much into the multinode. Ganesh said, I tried this before. It worked fine. That's cool. That's good to know. I'd love to hear more about that, Ganesh. If you want, if you don't mind messaging me on Twitter or anything like that, I'd be curious just about your use case. Not like the technical specifics, but what did you use it for, right? Was it like to share the lab with coworkers? Was it to share with a client? Was it to, yeah, I'm just curious about your use case. Or if you're comfortable just putting it in the chat, you can do that as well. Certificate management, obviously it's a lab environment, so I didn't look into the certificate management. Inventory, this is really cool. This actually by default, this is actually out of the box working by default. So when you deploy your lab, it automatically generates an inventory file, an Ansible inventory file. And so like for example, like here's a topology, right? A containerlab topology file. And then here's the generated Ansible inventory. So like, what was it? Probably like a month ago now, we were looking at Ansible on stream. And so like, could you imagine like you spin up this container lab to do all your testing, and for whatever reason you need an artifact in Ansible inventory for another process downstream, whether that be in a pipeline or if you want to deploy it in production, and for whatever reason you have these also as physical devices. I just think it's pretty neat that like it's already kind of creating those artifacts for you. You can even do grouping of nodes, right? Just like you would, you could group nodes in Ansible inventory. So this is kind of like Julio says, if you need a tester, let me know. Absolutely. I will definitely let you know. It probably, I don't know how much I'm going to be looking at this stuff over the next couple weeks. I'm trying to take a little bit of a break. But yeah, after the new year, if I start looking at it again, I will definitely hit you up, Julio. And Ganesh, if you provide, if you tell me your use case, and since you've done it before, maybe I'll ask you as well, and maybe let you teach us. So okay, so the inventory piece, I wanted just to touch on it before we kind of dive in the practical side. I actually thought about, because so Ansible, containerlab and Ansible both have like a YAML document as their inventory files, or as as a possible format. I thought of another really cool library that I really enjoy, being PyATS, and I thought it'd be kind of neat if I could dive into some of the code and actually potentially contribute to this project. Because one, I really like the project. I think this project is going to just keep growing and growing, as long as the maintainers stick with it, which why wouldn't you? I think this project will continue to grow, and realistically all it takes is for a larger company like a Cisco to be like, okay, We understand how important containers are, and so we've released our first suite of containerized iOS XE versions, right? So, I mean, all it takes is that. Think about that. You get a containerized version of iOS XE instead of doing this integration that I'm about to show you. Then you're there, right? We already have the platform, and once this, and I'm not picking on Cisco at all. I'm just saying, like, once a larger company like that makes that sort of move, obviously there's a lot to consider, but if they make that sort of move, there's no reason for the other companies not to, right? I mean, the other companies already are. Like, we talked about Nokia, Arista. There's some other ones as well in the list of kinds that you can check out. But I mean, we're almost there, right? So, anyways, I obviously really like this project. I definitely see a direction for it. But I thought about it. I was like, well, wouldn't it be cool if we could make a PyATS testbed, right? It's not, I mean, it's just like a topology file, like an inventory, but a testbed file. It's in a YAML format. It only requires, whatever's, you basically can pull facts from the topology file on the, on the back end, and you pretty much are there, right? So like for the CSR, if you look at the different kinds, right? We have a CSR, which, when a PyATS testbed, you have to identify the OS type, right? So iOS XE, obviously, for CSR. N9KV is obviously Nexus. And then XRV, 9K, and just XRV, those are obviously your iOS XR, right? So, like, you can make assumptions about those devices, and then the rest of it's kind of filled out for you. Username, password, IP address, host name, all of it's there. So, I don't know. It's just something that kind of popped in my head. Don't hold me to it, but yeah, if I get the little itch to contribute, I think that would be a very cool idea. So, yeah. And feel free, by the way, I know I'm kind of saying this out loud on stream. If you feel that you're like, oh, that's a good idea, I'm going to jump on that. Go for it. By all means. I will not be, if I see a pull request into this project that's like integrating PyATS testbed, I'm all for it. Hey, I just think that'd be a cool addition. Like, they already have Ansible, and maybe they choose not to do PyATS. I know PyATS still kind of has a Cisco flavor to it. Like, people think, oh, it's just Cisco. It's like, I mean, to a degree, yes, it was developed by Cisco, and it's used for their internal testing. But, like, I mean, look at Genie. Like, how many different parsers do we have? Yes, a majority of them are Cisco, but obviously, if it's being developed by Cisco engineers, it is going to have some favoritism. But I mean, you got Junos in there, Big IP. There's some other vendors as well. So it's like, we'll see. I mean, now I'm kind of just like making up scenarios, but I thought that would be kind of cool, was making a PyATS testbed. So, okay, I think that's it. Oh, the last piece is image management. Talking about tagging images, and this is more or less, image management isn't only for containerlab. This is for Docker images. So if you picture it in that light, kind of reading through this document is pretty easy to understand. Like, tagging images, that's very popular. That's a normal thing to do with Docker containers, Docker images. Pushing to a registry, exchanging images, all things you would do with Docker images, right? So, but no matter what, I would highly recommend you to take a look at these documents. I think they're very well written, and they have really good practical examples. And honestly, they're not that long. I mean, this is about image management, and I think that's pretty simple to, it's not that long. I always look at the scroll bar. It's not real tiny. I think we can handle it. Okay, so enough of that. Let's dive into an example. So let me go ahead and start my music. I always like having some music in the background. I think it started. There we go. All right, got a little music going, and I have an Ubuntu 2004 image or VM ready. So this one actually, I think I'm gonna use it as my DevNet Expert VM as well. I haven't decided whether I'm gonna just keep this one or clone it. But anyways, so you can kind of tell I was already kind of prepping for the stream. But so I already have it. Come on, words. I already have Container Labs installed, or Container Lab. Sorry, I keep saying Container Labs, but Container Lab installed. Went through the setup process. All I did was in my home directory, I created a folder called C Labs. You can name it whatever. I just called it C Labs. And in order for you to make sure you have it installed, Container Lab comes with a CLI utility. So you can just use Container Lab space version, and you can see the version, the latest commit, the date, and obviously 12.2. And it's very recent, so this is one of the newest versions. It may have came out with the new one, but I just installed it this past weekend, so I don't know. So trying to think what to talk about first. So going back to the documentation, and I'm going to jump between the documentation and the VM. I'm sorry. I was just trying to think about what page I need to go to. So I skipped over this page earlier for a good reason, because this is kind of the main page that we'll be using to kind of base our topology on, right? So as I mentioned, there's two different types of, there's different images, and the best way to see the different images is by clicking on the kinds dropdown. Some of these are container-based native, what I would call a native container, right? They're already containerized. They weren't meant to be virtual machines, like the Nokia SR Linux is and the Arista CEOS is, I believe. If I'm incorrect, I apologize. But I believe these out of the box are containers, right? So there's nothing crazy. You can pull them down from a Docker registry and start using the image right away. Where things get tricky are the Cisco images. So we'll be taking a look at this CSR 1000V. And you can see here that it is built using the VRNET. Of course, it takes me right back. Hold on, sorry. The VRNET Lab project. And this is the best way it sums it up. It's a VM packaged in a Docker container format. So what they do is they take the QEMU VM or the QCal2 image. So those familiar with other virtualized network simulation tools like EvenG, GNS3, CML, they have the QCal2 image, right? And that's a common format for some of these beefier VMs, right? And so all this project, VRNET Lab project, is doing is it takes that VM, that QCal2 image, and packages it in a Docker container. Don't ask me how. I don't know how. That's the magic in that project, the VRNET Lab project. So with that, what Container Lab, the maintainers and developers of Container Lab did was they forked that VRNET Lab project, and they basically made the appropriate changes to allow integration between Container Lab and the VRNET Lab project. Because the VRNET Lab project, I'll just open it up here in GitHub. Okay, maybe not. I'll just open up in GitHub. There we go. I was like, oh, don't make me lie again. Okay, so this is the forked project, but I want to go to the original project. And you kind of see, like, talking through things, if you've been here for a while, like, this is all like, I know we're not like reading off the DevNet expert like the lab topics, but like think about it. We're looking at Docker, where we have to understand Docker networking. We have to understand Git. We have to understand kind of how these projects are built and exactly how we can use them. Like, understanding how, like, what, I just mentioned, like, the project being forked. Okay, like, what does that even mean, right? So, like, whether we're actually studying for the DevNet expert on this stream, or the previous streams with CML or whatever, kind of have to understand, like, we're in it, right? So if you were tuning into the stream just for hopefully he talks about the DevNet expert, hey, we're not just for like I said, these last couple streams, I thought it'd be neat to dive into some of these products, but just so you know, like, we are kind of still in that realm. We're in that developer mindset. We're definitely outside of networking. Think of it that way, right? So, so here's the VRNet Lab project, the original. You'll see it, 817 stars. I mean, it's been forked 215 times, 77 people. So I would say it's a pretty popular project. And you can kind of read through, like, its documentation. But I mean, straight up. Run your favorite virtual routers in Docker for convenient labbing, development, and testing, right? So all that containerlab is doing is it created a fork of that project. Helty is the username, but you can tell Roman, he's one of the kind of the main developers of containerlab, forked the project and made some appropriate changes that would allow it to be integrated better into containerlab. So with all that being said, what we have to do is if you read through the CSR 1000V, it says to, it kind of gives a highlight over, what's the management interface, what's the data interface. It just tells you kind of at a high level. Use, admin, is to log into the device. But if you go to, I wish I didn't get rid of that page. If you go to here, kind of going base, you can kind of understand how VRNet Lab works. It allows the VMs, the VM-based images, which in our case is the CSR, to connect with other container-based network operating systems. This is kind of compatibility matrix. So building the images. So you see that we have to clone that forked library. I'm sorry, the project, which if we jump back here, you'll see that we do that, or we have done that. So it says VRNet Lab right there, just so you can see it a little better. VRNet Lab. So that's the clone. I cloned that project. And then you change into the directory and then enter the directory for the image of interest. So we'll just do that. I'll kind of just follow that just to show you all. So you'll see that we have and I'll just grep on it. We do have a CSR folder, right? And these are some other ones that are available to us as well, but we'll look at CSR. So within the CSR folder, and actually I'm just going to jump into this so that way it's easier. And actually, if you read this, it will tell you to, So after you change into the folder that you want, follow the build instructions from the README in the image directory. And you'll see here that we're in the image directory. Oh, I'm sorry. We're in the image directory that we want. And this is how to build it. So basically put the qcal2 file in this directory, right? So we have to copy the qcal2 image. the way I got the QCal2 image is actually from CML. So CML has a whole ISO file, and I think I talked about it in the last couple streams. There's an ISO you attach to the CML VM. Well, in Windows, you actually can open that ISO file, and then it shows the list of the QCal2 images or the VMs that CML uses. So I purchased a license for CML, and I'm using an image, the CSR image from CML, in order to run this. I want to make that perfectly clear because it's otherwise you're getting it through an illegal channel. You want to make sure that you have proper licensing to do so. So just want to kind of put that out there, so that way people aren't like, oh, hey, DevNet Dan streamed about getting this QCal2 image. Wonder where I can find it. Or if you message me later, I'll just tell you you have to purchase CML, or a year license for CML. So anyways, I'm using the CML, the QCal2 file for the CSR, and I transferred it into that directory. And the way, obviously we can verify that. Here you'll see, down here you'll see the CSR 1000 QCal2 image on top of the other 3 files that were native, in there by default. So then you run the make docker image command. So what that does is it runs a make file. And so if you're unfamiliar with make files, just kind of think of it as like a macro. It can run like a list of commands, and think of it as like an install script almost, really. But there's a lot of use cases for it. So anyways, it does creates a Docker image, and Docker image refers to kind of a subset within that script. So it doesn't just like create a Docker, like it creates a Docker image, but like Docker image isn't like a out of the box Docker command, right? There's some other things in the background happening that are built into the script. So and you'll kind of see that here. The resulting image is called VRNET /VR-CSR. So like, the naming of this image didn't just happen out of thin air. That was part of that make file script. You can tag it with something else if you want. I kept everything default. Obviously, it's the best case scenario. Just keep it default, so that way you're not troubleshooting your own problems. And then push it to your repo. The tag will use the same image. So if you use 1743 serial QCal, I believe mine's 1732. Yeah, 1732 serial QCal. Your final Docker image will be called VRNET CRSR, which that's what the default image is called, and then with a tag of the version. So in this case, it's 1773, which that doesn't even line up with the example. I will show you my example. VRNET Lab, VR-CSR tag 1732, and you'll see I'm using the 1732 image. So that tag was automatically created. I didn't have to do a thing. One thing I will note is after I created the image and used the make docker image command, it tried booting up the Docker image, or running the Docker image. You can cancel out of that once it's been tested, and you can see here it's been. That's what they were testing, but you can boot it up, like it boots up, but you can cancel out of it. That's what I did. I did cancel out of it and then did this Docker run command. And the reason I did that is so I let it boot up, and then if you let it boot up, it actually will tell you whether the container's in a healthy or unhealthy state. I let it get to a healthy state, and then I stopped the container, because what that told me was, okay, the configuration works and there's enough resources that allow it to get into a healthy state, right? So, because initially I had this on, was it WSL? I think I had it running. Yeah, I had it running. I put it on Twitter, I think. I had it running in my WSL instance on my local machine here. And my local machine has 16 gigs of RAM, but like it's an older. It's it's a Windows machine with a bunch of other processes running, so it didn't really have the resources. And I don't even know how much resources WSL has out of the box. So it basically went to an unhealthy state and just kind of pegged itself. So that's why I moved to this VM, which has enough resources available. So, anyways, I booted it up, made sure it got to a healthy state, and at that point, I was pretty much ready. And you see here, like once it's in your Docker images, you're good to go. You have an image ID, it's created, has a size, everything like that. You're now ready to build that topology. So if you go to, let me back out a little bit. Yeah, if we take a look at this first lab.yaml file, this is kind of my first topology. And like I said, it's pretty simple. I created a name, 2 nodes called CSR R1, CSR R2. That kind, remember, if you, back in the documentation, it's called the, under kinds, VR-CSR. So I use that same kind and then the same image. So that's kind of, like I said, this is where like it's more verbose than it needs to be. I probably could create or override the VR CSR kind and apply the image as like, talking about the template. So I could have made like a template under the kind section under the topology and then assign these nodes to that specific. Anyways, the point I'm getting to is there's many ways to create this one topology file. And then the only thing I want to point out besides that, because you can see here the link, there's one link that connects CSR R1 ETH1, the interface ETH1 to CSR R2 ETH1, right? So it's just a point-to-point link. But the one thing I want to point out is this environmental variable called boot_delay30. This I actually found kind of interesting. See if I can find the documentation for it. Yeah. So in the VM-based router integration page, it does give you a warning like, hey, simultaneous boot of many QEMU nodes may stress the system, which if you've ever ran multiple CSRs in like an EVE-NG, for example, and tried starting your lab all at once, or even in CML, you can peg the system. It's no joke. So, I kind of took that knowledge and was like, all right, I definitely don't want that to happen, especially like, we're dealing with containers now. I was like, I don't want that to happen. So it mentions that you can delay the boot process, allowing, nodes to boot gradually. And you can do that by setting an environmental variable called boot delay. So I literally just took this example. I thought 30 seconds was plenty enough. So I just added, under the environmental variable key, I added a boot delay for 30. So, and that's in seconds, so for 30 seconds. There's also memory optimization. Didn't really dive into that because I didn't have too many. I have 2 routers. So, so yeah, so that's why the boot delay is there. Okay, so we have our topology, we have our CSR images, we have our topology. Now let's build this thing, and we'll go back to quick start for that. So at the bottom of quick start, deploying a lab. So it's containerlab deploy --topo and then the name of the topology file. So containerlab deploy --topo and then the name of the lab, and in our case it's just first lab C lab YAML. Oops, sudo. Actually, up arrow. Oh, and by the way, I got, like I said, I had this working this past weekend. Julio says -T for short. You're right, -T for short. And you know what? Just because you're here and you recommended it, we'll use that. I had this working this past weekend. I haven't deployed the lab really since, so we'll see if the demo gods are with us. There we go. All right, and let me see if I can spread this out a little bit more. Just like that. So you'll see, we created the lab directory. So clab-first lab. So if we go here, we'll see clab-first lab. I want to just quickly show you this in here. You'll see that Ansible inventory file, right? And look, it just out of the box, it did this, right? It checked the topology file and then created an Ansible inventory file. Created a Docker network, named it CLab, the 172.20.20/24. There's the IPv6 subnet, and the MTU size is 1500. Created containers for router 1, router 2, the virtual wire between ETH1 on each router, and then it added those host entries. And you can't underestimate logging as well. Like, I know all these are log messages, but like, how helpful was that, right? I have all the information here within less than like 20 lines of terminal output. So yeah. So now we have the lab deployed, right? So it's like, okay, well, what do we do next? Well, now it's time to actually log into one of these devices. So you can connect a couple ways. One is because these are Docker containers, you can actually get into the bash shell of them using Docker exec. But as traditional network engineers, we're going to SSH into them. And we're actually going to use the IP address, right? So the default login is admin. So we're just going to SSH admin at the IP address. So let's go ahead and do that. SSH admin at, and the IP address obviously is over here. So 172.20.20.2. And I don't know if these things are booted up yet, so there's a chance that it may error out here. Because remember, these things are beefy. Like, it takes a while for these routers to kick on. So, so we'll actually just let it sit. I don't want to break anything. But you can see it. It's a nice table and with all the right information. Now since it created these host entries, you technically could SSH to the host name as well, and maybe that's what I'll do. I'll just have the command lined up. So we'll do SSH. Theoretically, I haven't tried this. I will throw out the disclaimer. Why is it not pasting? Okay. I will kind of throw out there, I have not tried the host name. I was kind of just rolling with the IP address in my testing, but we'll try it here soon. I'm trying to think, is there anything else we gotta? I think that's about it. So for the sake of time, so actually it's kind of interesting. I had so for me, I was like, okay, after I got into the devices, I was like, okay, how are they connecting, and what do I do to verify connectivity, right? Because obviously, like, okay, great, you have a virtual wire connected. What can I use to test it? So I actually enabled CDP and LLDP. And CDP never worked, but LLDP did. I thought that was interesting. And then I also got BGP working across the link as well. So, and, a neighborship established and whatnot. So I thought that was kind of neat. And we'll like I said, this is a brand new setup. You guys just saw the the topology deployed. So we will verify that. Once the lab's up and running. But yeah, we'll configure, we'll just do a basic BGP configuration, and we'll enable LLDP as well. And oh, maybe it's not set up yet. Or maybe it is. Let's see. which it may kick back the same error. And if this doesn't work, host key verification. Oh, so with key exchange identification connection closed, I knew it was an issue with the SSH key, but I thought it may prompt me to, you know, accept and say yes, like that's fine. I know I don't know about the SSH key. So let me just cut it out, or let's just get rid of it. And then what we'll do is we'll try the hostname again. Hey, there we go. And then I just used admin and check it out. Just like that. Just like that. And you, like, think about this, right? We literally have 2 containers. These are containers set up, right? For Cisco CSRs. Like, this is the running config, but like, just for giggles, let's see. Show version. Version 17.3.2. Now you have all the features of this release, this iOS XE release, in a container. So like, I mean, it's endless, right? netconf. Okay, so the only thing I will preface as well, just because I just saw it, the throughput level's 1,000 kilobits because I don't have a license. There are ways you can get like a trial license, I know, but just as a heads up, CSRs out of the box don't have much throughput. So I will let you know that, like, don't use T-Rex or any sort of traffic generator on these devices because it won't work or you'll hit your limit really quick. It's probably just enough for maybe some controlled traffic. I mean, honestly, if I got BGP working and there was like a flap, it might just be the link being 1,000 kilobits per second. Anyways, so yeah, but 17.3.2, you have all the features there. You can test out, but what's the fun in that when we can jump to, by the way, I deleted the SSH key for the other host because I'm about to jump into that one. Boom. So if you jump into this one, it's router 2. It's been up for 7 minutes, and you'll see 17.3.2. I already passed it, but right here. So, oh, that's pretty interesting. So now we're good. What am I gonna do? Oh, yep. We said we were gonna enable. We'll do LLDP first. And then we will do BGP. So let me just open up another terminal real quick. We'll do SSH admin at, I'll just do the IP address because I know it. 2. Wait, am I in router 1? What router? Oh, this is router 1. Oops. Alright, so we'll just SSH to it. So now we're in router 2 on this tab and router 1 in this tab. LLDP, or just to kind of show you LLDP status, right? No? Show LLDP status. Show LLDP. We'll just do show LLDP. It's fine. It's been a minute. Okay, so you see it's not enabled. LLDP run enables it globally. We'll do show LLDP is active, right? It advertises every 30 seconds, but at this point we should see we'll jump back here. So it's active here as well. I do remember this taking, I mean, it may actually take like 30 seconds, but. Okay, so we'll go back to LLDP. So it's active. Oh, I'm an idiot, that's why. We don't have the link up. And this is what I wanted to show you in the first place. So if you do show IP interface brief, you can see gig 1 is up, and already has an IP address assigned to it. They're the same IP, and that might just be a management thing. I'm not too sure. But that's the management connection, you know, we were looking at before. But gig 2 is the connection between the routers, that point to point that we defined. So if we go to gig 2 and no shut, we shouldn't need IP connect. Oops. And no shut. We do need the IP connectivity. So we'll just do 10.1.1.2. And we'll just do a /24. I know it's a point to point. It'll be fine. So 10.1.1.1.2 is on router 2, and then 10.1.1.1.1 is going to be on router 1. And then LLDP should be coming up. Just make sure. And I promise you this worked before. That's fine. So what we'll do actually is we will configure BGP. So we'll just do eBGP. So we'll just do 65,001 remote. I'm sorry, neighbor, and we'll say 10.1.1.2 neighbor. I'm sorry. Jeez, I got my words backwards. Remote AS is 65,002. So that this is from router 1's perspective, right? So if we check out the BGP config, very basic. We're just saying, you know, router 2 is our neighbor, and the remote AS is gonna be 65,002. So let's jump into router 2 and say 65,002. Neighbor is 10.1.1.1. Remote AS is 65,001. Right? And if we do show IP BGP summary, that message is sent, and it's in an up state. See, it's been up. And if we just to show you beforehand, you can see it's only connected, you know, connected routes. But if you just ping across the link, actually it still shows connected, never mind. But we can ping, you can see from router 1 we can ping router 2, right? And then vice versa. If from router 2 we can ping router 1. And it'll probably still show as connected because it's point to point, yeah. But like, let's say if I added another interface, which I'd have to define that in the topology. But let's say we define gigabit 3 and we had another IP address, you know, different range, or different subnet, then, you know, that would be learned via BGP in router 1 from router 2. So let's check on our good friend LLDP. Just says it's active. I did have CDP enabled last time, but I don't think that should be an issue. Oops. No, CDP doesn't show CDP. Neighbors? Oh, you know what? There we go. I was using the wrong command. I apologize. I was using show LLDP, which just shows you, like, you know, the advertisements, the hold time, and all that, when I should be using LLDP neighbor. So there you go. And just to show you from this perspective, CDP doesn't work, so, which is fine. But you'll see like CSR R1 example.1 or example.com gigabit 2, or that's our local interface. Or no, that's that. Yeah. But yeah, so you'll kind of see LLDP works, and then from this perspective, you can see it's been working. So Julio says, can you possibly advertise a loopback? Good idea. So we'll just do loopback 0, and we'll just say 222. Good idea. All right, so loopback 0 is created with an IP of 2222. Let's see. I'm sorry. Yeah, Leo says versus creating more interfaces. So, but basically create a virtual interface instead of having, let's see if we can ping it. Create some virtual interfaces instead of like generating new physical interfaces. So 111's directly connected. Oh, no, I have to put it in the network. Let's see, 65,000 to, yeah, and I think it's what, a mask, yeah. You're testing me tonight, Julio. You're testing me. This is back to, gotta pull out the BGP knowledge. So now, yeah, there we go. So now it's being learned. The issue, it was BGP. I was like, there has to be a way that you are like, you're telling the router to advertise, like EDGE, ERP, OSPF, like you provide network statements that cover subnets. And I was like, oh yeah, duh. BGP has the same thing, so yeah. And if we go to router, in router 2 here, if we do IP, or I'm sorry, IP route, and then just so you can see, there's no routes coming from BGP. But what we're gonna do real quick is advertise the loopback using the network statement. Mask 255. So now what we're doing is advertising 1111 over BGP, and you'll see it 9 seconds ago we got via 10111, we got the route to the loopback, and there's the BGP route. So, but, and just for giggles, we'll ping it. There it is. Julio, I appreciate the recommendation, that suggestion of creating a loopback. That was clutch. All right, and that's it. That's pretty much it, guys and girls. So if you have any questions, feel free to put it in the chat now. This kind of wraps up, like I said, this kind of wraps up my year with streaming. Yeah, I'll be out the next couple weeks, just kind of unwinding, enjoying the holiday. I'm sure I'll talk to you all on the internet somewhere, Twitter. But yeah, feel free to let me know, to message me if you have questions about ContainerLab or anything network automation. I'll be there. But yeah, next year we'll take a look at more of the DevNet expert topics. It'll be a little more focused, like I said, on that. There will be streams like this where we take a look at specific platforms, specific tooling that I find or get recommended, like in this case, that I find really cool. So it's not just going to be DevNet Expert, but a lot of it will be because, May 2nd's that first test day. So, man, it's going to come quick. It's going to come quick. So, I wanted to end it real quick by just saying thanks to everyone that's kind of tuned in. There's been a few people that have definitely stuck with me, especially in the chat. I really appreciate everyone being here. It really means a lot. I know what I'm talking about and what I go through, with material. It's not exactly the most exciting to everyone, but I appreciate everyone being here. I actually wanted to mention as well, thanks to you guys, I actually just noticed today that I got to 100 subscribers on YouTube. So thank you for that. It's definitely, it's a small feat, but I think it's pretty good for kind of just starting this YouTube adventure roughly 2 months ago. It was the beginning of October, I think, was my very first live stream. And I was streaming to Twitch and YouTube at that time. So a little more, about 9 weeks ago, I guess, 2 months and a week. But it's been fun. I've definitely feel like I've connected with a few of you guys, and it's been a good time. So I hope everyone has really good holidays. I know a lot of people are going to start taking time off next week, and obviously for the following 2 weeks into the new year. So have a safe and awesome holiday, and as always, I'll be around, and I will look out for my tweet about coming back and come my first stream back in the new year. I'll definitely provide some more context as we get closer to the new year, but in the meantime, definitely pay attention to my Twitter probably tomorrow. I definitely have something related to what we talked about tonight in a blog format, potentially. Kind of gave it away, but for those that stuck around this long, I don't mind giving you guys the secret. So there will definitely be a blog posted tomorrow on a lot of this content. Hopefully, if you kind of got a good picture of it tonight, you can then see and read about it tomorrow as well. So it will be out tomorrow, and I will definitely be sending a tweet out. So that's all I have. Thanks everyone for tuning in tonight, and I will be talking to everyone in 2022. All right. See y'all.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun.